Hi, I'm Blake from baaelectronics, and we're actually going to be doing an electronics thing today. What a concept. These three controllers actually have, well, they're identical, but they have one thing in common, and that is they're all broken. These came out of an ATEC M3X pitching machine that is currently in operation at .4 baseball. And specifically, these two boards to my right are of an older revision, which has kind of a major design flaw. And that is, if you look at both of these boards, you can see that the bridge has been completely blown apart. In this one, it's kind of moderately blown apart, but it's still a big bulge of brokenness, like myself. This is a much newer version of this board, and this is the one that has actually been in service for over a year now. And this one has a very different problem, but it's actually an easier problem to fix. And it is actually the problem we will be fixing today. So this neutral line here, let's flip this around. This neutral that usually connects to the power lead that powers the main board has pulled off of the circuit board. I suspect this was from a baseball hitting the power cord and it just completely pulling out the power cord from the machine and pulling this lead right off of the circuit board. Now, looking at this board, you can kind of, well, you can kind of immediately tell where this trace is going. There's a big pad across this entire spot that goes to this section and the two power transistors that would be right here, as well as some, I believe, 300 kilo ohm resistors. And there are no pads left to solder to this. So the only way that I know how to fix this is to put this thing back in the board and manually solder little wires to each of these pads, or at least from pad to pad, and then one master pad connects to the lead here. Now, there's actually more on the other side of this board because I'm familiar with how these are laid out because they break so often. So there's actually another thing on the other side that we'll have to solder to as well. Thankfully, the pads on the other side of the board are somewhat intact, so hopefully we can use those to at least keep this in the board. And then we'll just solder wires to the top side. So that's the plan. I don't know how good that plan is or if it's going to work, but we'll find out here very shortly. Now, as you know, project success is usually based on if you have the right tools for the job. In this case, I have my multimeter, which we'll be using for continuity testing. We'll start with that. I've got a flathead screwdriver, which you'll see what we need that for. A multi-tool, which I'm just using for the pliers, and some automatic wire strippers, as well as this piece of 8-gauge wire that I pulled from an existing installation over at .4 baseball. That will be taking the strands out and using this, which we will be using as our fix wires for the main board. I've also got a soldering station over to my right hand side that you can't see. It's a WESD 51 that I've had forever, and also some leaded solder to hopefully redo those traces with the strands from the 8-gauge wire. So whether it works or not, you're going to see how we do it. Okay, so the first thing we're going to do here is get the board out by itself. So I'm going to use my pliers to pull off this last remaining power connector, and these are on there real good. Who knows, if you've got this, you really got to pull on that, and then it'll pop off. Don't break the traces off like the idiot who smashed this one off. Now on the other side, you're going to see what a year in a baseball cage will do to equipment. Let me focus this in here. There used to be this big flag over here that said turn them all to 5 before you start it up. That was a design flaw with previous revisions where it would crank them up. It would just blow up the board when you turned it on, which is fantastic. So in this case, we're actually going to turn it to one extreme or the other. So I'm going to turn it to 1. Makes the most sense to me. Then there are little flathead screws on each wheel that we're going to undo with the flathead screwdriver. Just a little turn and they will come off. The reason why we go to one extreme is that way when you put it back on, you just line it up with the number and then screw it back down and you're good to go. Now this dust we've affectionately called the ball dust because it comes from hitting brand new baseballs off of brand new nets for a very long time and having that dust settle absolutely everywhere. We're going to undo these little nuts, which are actually very loose because this thing's been in service for a year and oh, look at that. Been in service for a year and hasn't been cleaned since. Because who in their right mind would clean underneath the potentiometers and take off the lock washers and put those all in a magnetic parts tray over to this side. Along with the wheels aren't magnetic, but put them all in the same spot. Then this board will just kind of come right out. And if we look here, we can see our problem right there. Now on the other side, like I was saying, there are traces on the other side of this thing, which makes this repair interesting. Now this is a very basic repair because I'm not a board technician, nor will I ever will be. So the only thing that this trace is connecting to, looks like to me, all these pads here, and then we got one pad that goes over to one of these transistors or VRs or whatever they actually are. I didn't bother to look up the data sheet. And then they go way down here to these 3 pads, which actually don't look like they're really connected to anything. But there is this giant series of pads all over here that interface with the ground on another part. So we'll probably have to bridge those as well. It also goes to here. So that's what I have the multimeter for, is for continuity testing. We're basically just going to see where all of these traces go and what we actually need to make sure is connected to the flag and connected securely. This is an auto-ranging meter, so all I do is put it in the ohms position and turn on the beep because we want to be as annoying as possible. We're basically just going to map out where this goes. On the top side of this board, we have the VP3000K right next to it, and that's very clearly connected. So all these pads right around here, just any pads that are close to where the neutral is, we can see the bus bar that goes along. I don't think it's a bus bar, it's just a giant trace that goes across this entire thing. But nonetheless, this trace goes to all these things with a continuity of near 0 ohms. So that's what we need to solder to on the top of this board. We need to solder to this center terminal here, or actually the side one. We need to connect to this resistor. And if both these are connected, then these pads will be connected because that's connected there. And if we go between the pad and the 300K, it is also connected there. So we just connect this flag to the major parts here, and we'll be good to go. On the other side of this board, however, we can see the pads here are still kind of intact, so I can use that as a test point. And then also there's one major pin here that it clearly connects to, which is right there. So we'll jump from this pad over to here, as well as I think I'm going to put a few strands on some connectors up here because this entire thing is a power bus. So all of these little parts, all those two, all these are connected to the same thing. Theoretically, I could solder this in here, put a wire from here to this pad and be done, but that creates some extra resistance. It might burn that trace up or do any other thing. So I'm going to solder from this one to this one, and then from this top one to just some random points up here, just to give another point for current to flow through, just so we don't burn anything up. What I'm going to do real quick is just make sure that this is straight, because when it was pulled out, it kind of bent it a little bit, so it won't actually go into the board. Make that nice and straight. Yeah, that looks pretty straight to me. So let's check that it fits in the board. Indeed it does. There's enough material left on these that these pads on the bottom are fine, even though the solder was broken. We can reflow those and get this bottom trace working basically normal. So we might not even have to do traces on the bottom. The top, however, yeah, we're gonna put some fixes on the top. I'm gonna use a fume extractor in like 5 years. Hello, and welcome to the corner of the office that nothing really ever happens in, except stuff that makes little lead balls that I don't really want in the inside of my mouse. So what we're going to do, we're going to cut off little pieces of this stranded wire. This is 8-gauge stranded wire, which is really thick. We're going to use these individual strands to make replacement traces between the components that, well, don't have a trace anymore. First thing I'm going to do is actually secure this this neutral pin back into place where it was. So we're going to go ahead and press it in where it was. Just press it in nice and tight. I'm actually going to use some pliers here. Not hard enough to break the board, but just hard enough to, you know, make sure it's in there. There's that. It's in pretty well, I'd say. Oh yeah. So now we're just going to solder this side of it. Go ahead and tin this iron first. So this just actually make sure that we're going to be able to actually solder those wires together. Now we'll get to these traces. So you usually want to heat up one side. I didn't know this would turn into like a basic soldering tutorial. You're going to heat up one side of it, touch the solder to the other side, and it'll just kind of flow in itself. Put as much on as you need to. Heat that up. It takes a while to heat just because it's a giant metal thing that actually looks a little cold. So I'm going to turn up the temperature to about 690, slightly higher temperature than I might normally use for something like this. Make sure it's nice and flowed. Take it away. That one is noticeably not as shiny, so I'm actually going to bring this back down to 640, which is what I was using earlier. Get out the old blue gun here. Anyone who's worked in this industry for a while knows exactly how terrible this thing is. Heat that up. This is a weird angle. We'll do that. There we go. Okay, well, I'm just going to resolder that one. Heat one leg. Make sure it's hot. Now it's hot. There we go. Flowed nicely. Take it away. Nice and shiny. So yeah, that temperature change earlier, not a good idea. I'd say don't go higher than what your solder actually calls for. Take one of these pieces of stranded wire, and we're just gonna solder it across those two. So let's tin the tip first. Go ahead and solder that on. There we go, no cold solder joints here. Then we'll measure how long it needs to be. And then just Yeah, it's not hot anymore. Make a little bend right where we need it to go. Cut it off where it needs to go. Actually, I might bend that the other way there. This is the official Weller smoke absorber as well. This thing should be quite well, I guess by like 2005 standards, it was pretty quiet back then, but yeah, I didn't start soldering in 2005. I think this thing is just that old. So we've got, make sure that's, I'm going to reflow that real quick since we're soldering to another big lead. Take it off. Still nice and shiny. Looks like that one is done. We've got one more on this side that I don't even think these are necessary, but I'm gonna do it just because these traces don't really reach through the bottom of the board as far as they did. So yeah, I'm still gonna make the fixes on this side. You know, even if you're not fixing this pitching machine, this is still just some good stuff to remember when you're fixing boards like this and putting in traces. Or you don't want to go longer than you need, or else you might accidentally bridge something that you don't want to. And then we'll just get in here, bit of solder. Alright, our traces up here are, turn that off, thank goodness. Looks like our traces are repaired. Okay, I am indeed going to reflow those parts just because this isn't, no, this isn't really in as far as it was from the factory. So we'll just make sure it's actually, you know, that we can actually solder to it and stuff. Get the other side here. This also serves to kind of, oh my freaking goodness. Yep, safety glasses, always a good idea. The flux to fling off into your face. It's not fun when you get flux on your face or in your eye or something like that. Not fun at all. Okay, we're gonna make a bridge. We're actually just gonna do two because it only looks like we need two. I'm gonna bring this close. If you have a look on this board, really the only things that we need to, the two major things we need to connect to, this part and the top of this resistor. This power transistor has already been soldered. You can tell because it's warm. That's fun. Yeah, top of that resistor, side of this part, and we should be good to go. Actually, all these are kind of warm, so you can tell the this one's exceptionally warm. You can tell those giant bus bars are definitely conducting the heat. If they're conducting heat, they gotta be conducting electricity, right? Okay, this might be difficult to actually get in there with this whole bundle, so I'm gonna cut a little piece off. We're just going to use this strand. Well, the trace isn't broken, but the pad is gone. So here's that neutral lead. Definitely going to have to get in here with pliers because there's no way I'm touching that. Alright, I just bent this thing into a little hook so that we can solder it basically flat on there. My hands are really shaky. That's why I will probably never be a board technician. Put this solder underneath here. Maybe it'll keep it from moving around all over the place. Yeah, it's taking a while to heat up just because it's, you know, it's a giant metal pin. How I'm seeing it, but it's so difficult to get the camera in here and everything, so yeah, you'll just have to deal with that. It is not hot. Yeah, always check that, because more often than not, you find yourself just grabbing it and go, ooh, that's pretty hot. Just gonna make it touch pad on the, there we go. Yeah. Now the cool thing about this, once this is soldered, we can reflow this, make sure that it's, you know, it's real good to go. I feel like this isn't as big of a thing to solder as that giant pin was. So heat up one side of it. Yeah, this is leaded solder, and this board is probably soldered with lead free, but did I really ask? No, I didn't. Look at that, worked just fine. Alright, that is nice and flowed. Right there. So, we don't want all that current just to be going through that tiny little strand there. So, I'm actually going to do a second one. I already have a little piece of wire. So we can go ahead and bend just the very end of that. And solder it on. Of course, these pliers are too large. Heat it up till it melts. Still shiny. So, that don't look like no cold solder joint to me. Cut that short there. That off. And press it down. You want to try to not bridge off of anything else, just because there's this capacitor right next to it. This is a surface mount board. Not a whole lot of room. The end of that is not touching anywhere, so that shouldn't be a problem, that little longer than it needs to be thing. I've been calling this a resistor the whole time. It's a diode, yeah. Okay, here we go. Why did I think that was a resistor? It's not a resistor, it's a diode. There's a reason why neutral goes through two diodes. You don't blow something up. What it looks like to me is we've got two diodes going between, I forgot that, two diodes going between line and neutral over here. That makes sense. Same thing with these two over here. This is just kind of circuitry stuff. Put two diodes across here, then the motors, when you turn the thing off, it doesn't like send a giant surge into the board and blow it up. Instead, these diodes, they just don't let it blow up. I kind of want to add another trace just because I feel like one of these isn't enough. I'm going to add another one just to be safe. And tin this side. This is becoming a real Frankenstein's monster kind of thing here. This is meant to work until I get a replacement board from ATEC, the manufacturer. That's tinned. Oh, my hands are shaky all over the place. Of course, the wire's bent the wrong way. It'll have to work. And it looked like it did work. These are actually the only wire cutters that I currently have. So that's why they look giant compared to this board. And these are also the only pliers that I have right now. They're pliers in a Leatherman Wave, because I don't just have regular pliers. So that's looking ready to go. Man, I've almost gone through a whole CFast card just recording this. Hey, that's looking pretty soldered to me. Just go ahead and reflow this. This is at 650 degrees, by the way. That melted just fine. I think that'll work. Will these small wires end up becoming fuses when we turn this thing on? I actually don't really know. Just because, you know, these parts are kind of small, don't you think? But, you know, we just did a very basic level board repair of putting in that neutral pin and continuity testing everything. And I dare say this thing will work. So that concludes the video. I've almost gone through a whole CFast card recording this. If this works, you'll see security footage at the end of this video of it working, but no, I'm just going to screw those potentiometers on, and that'll be it. Thank you for watching. Hoping your ATEC pitching machine isn't as terrible as this one.